Welcome to a Wild Math Wednesday, everyone. And here we are taking a look at primary trigonometric ratios still. And we are going to be looking at how does one find the angle measurements when we aren't given any angles. If we're given the side lengths of a right angle triangle, we can use the inverse operations to find angles and solve for angles in different situations. So let's take a look at what we're talking about. Let's say we knew that the sine of some angle was 0.5674. Okay, and I'm going to draw a triangle that's going to have that sine length. Okay, so here's what it could look like. This triangle might look like this. It might have an angle there, like that. It's going to have a right angle somewhere in it because we're talking right angle triangles still. This is some angle A. I don't know what angle A is yet, okay? But I know that its sine is this. So what that means is if this was side length 1, this would be side length 0.5674. This is this type of situation, okay? Because this is the angle A, and if I analyze this angle and I think about what the different sides mean to this angle, this is opposite that side, and this is the hypotenuse. Okay, the hypotenuse is 1, and the opposite side, this is the opposite. All right, so sine A is equal to opposite over hypotenuse, SOHCAHTOA, S-O-H. Okay, so sine A, in this case, is equal to this divided by that. Or, another way of writing that, for those of you that are really sharp, know that anything divided by 1 is itself. Okay, this is sine. This is a situation where we have sine of some angle is equal to that. Let's say I want to discover what that angle is. Okay, we're not going to do this. I'm not going to ask you to do this, but you can absolutely use guess and check. And I want to start by showing you guess and check because it's useful to know, like, there are multiple methods to solve a problem. All right, so I'm looking for some angle A that when I take the sine of it, it gives me this. Now, I know a lot about trigonometry already. And I know that the angle 30 degrees, this is going to be my first guess, okay? Maybe I draw a scale diagram here. This is not a scale diagram, but it's close enough. This is a little bit longer than half of that. And that to my eye looks about 30 degrees, would you say? About 30 degrees is less than 45, right? So here, I'm going to guess 30 degrees. So what you would do if you're using guess and check is open up the calculator that you closed for some reason and put it over here. And you're going to type in 30 and take the sine of that. And then you're going to find that that's exactly 1/2. Okay, so I already knew that. I already knew that was going to be really close to this value. So the value of sine A in this case, let me just shrink this just a touch. So the value of sine A is 0.5. Now I want something that's a little bit bigger than that because I'm looking for 0.56. So I'm going to guess an angle that's a little bit bigger. Let's try the sine of 35. That's 0.57, okay? 57357, blah, blah, blah. 35 returned 0.57, a little too big for our liking, but really, really close. Right? Really, really close. So let's try 34. And I'm sure that this is the answer. Do you know why? Because whoever created these PowerPoints for the CCI math department, man, they love Fibonacci numbers. And I love Fibonacci numbers too. So I notice these patterns in these numbers. If I take the sine of 34 degrees, 0.55919. Okay, so pretty close. That's 0.56. Okay, and then I can try 34.5, and that should be very, 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 very close. Because you see, I was too big there, I was too small there, so I'm going to try something right in between those two angles. 34.5, and you're like, Mr. Jennings, this is so tedious. There, that's close enough for rock and roll, okay? We want something slightly bigger, 34.55, something like that would do it. Okay, if we wanted it to the nearest half degree, we've got it to the nearest half degree. So this is 0.56. I think that was 566 or something. 566, yeah. So within a thousandth of a place. All right, cool. So that's how you guess and check. And you don't. You're not going to do that. I'm not going to ask you to guess and check. I'm going to teach you how to do this algebraically. All right, so what you're going to have is you have an equation. Sine of some angle A. Remember, this is an angle that exists in a triangle where the ratio between this side and that side is this. Okay? Sine A is equal to 0.5674. Now, I can't divide both sides by sine because this is an operation I do to A. I need the inverse operation. Right? And the inverse operation of sine is sine inverse. So what I'm going to do is I'm going to take the inverse sine of both sides. Basically, I write this as my next line. A is equal to sine inverse of 0.5674. Okay, what this means here, sine, it's not read as sine to the -1. This is read as the inverse sine or sine inverse. Okay, and so the sine inverse is saying, given that the sine of some angle is this, find me that angle. That's what this operation does. You will find it on your calculator. Usually, you will find this on your calculator as the second function to your trigonometry functions, okay? So you're going to probably have to find the shift key on your calculator or something that's going to give you second function to find these. And you'll find the inverse sine, the inverse cosine, the inverse tangent, and don't worry about these guys. That's grade 11 stuff. Okay, so let's clear out my calculator. Let's copy down this number, 0.5674. And then we are going to say, find for me the angle that would produce that. Oh, it's 34.569. So 34.57. So we were very, very close there with guess and check. Okay, so then we would say this A is, change color, purple. The angle A is equal to 34.57 what? 569, yeah. So we're just around there, okay? And that's already way, way, way more precise than we need. That's to the 100th of a degree of precision. And remember that an angle that's like 1 degree is like that. It's like barely opening at all. So very, very accurate. Okay, so that's how you do these. Let's do cos B, this one. Okay, so I'm just going to punch it on my calculator and you'll see how fast this is. If I have this one, so I just put in there 0.7523. This is my desired thing to find the angle of. Again, this is some triangle where, and it can be helpful to draw these triangles. So let's do that up here. This is some triangle that looks like this. Okay, and why am I erasing here? There. So this is some triangle, and it has an angle B, and its cosine here. Wow. Yeah, I'm getting all of this happening and where I lose stuff. Here. So if this is angle B, the adjacent side is this side, and cosine is K, C-A-H. Cosine is adjacent over hypotenuse. So this is the hypotenuse. This is the adjacent. This is the opposite. We're not using the opposite in this problem here. If this hypotenuse were 1, this side length would be 0.7523. Helps to imagine these things. And then I can imagine if this is 1 and this is 0.7523, I'm expecting an angle returned here, maybe like, something like, less than 40. Wait, is it less than 40? Yeah, it's less than 40 degrees, but it's pretty close to 40 degrees. Okay, so here, trigonometry, I go second function, I go the inverse cosine of that, 41.2. See how good my guess is? It's because I've seen a lot of angles and I've seen a lot of cosines. So I have these kind of fishy tables in my head that are just there. You're going to build that by practicing. Okay, tan C. Okay, so last one. Clear everything out. Not going to draw, I can draw a triangle. We're reviewing here, so we'll draw all the triangles that we need. Okay, so let me erase all of this here. Here, I'm drawing some triangle that has a ratio for tangent here. Tangent is TOA, right? Tangent is opposite over adjacent. That's what tangent is. So the opposite side is going to be bigger than the adjacent side because this number is bigger than 1. So if I have a triangle here, and it might look like this, okay, where this side is the opposite to this angle C, okay? This side is the opposite. It's 1.6098 long. This one is 1 long. That way, this divided by that would be that, okay? So I'm predicting that this is going to be bigger than 45 degrees because, a little tip here, a 45-degree triangle, this is 45 degrees. Well, then this side is also 45 degrees, and this side is 90. Okay, so 45 plus 45 plus 90 is 180. If this side is length 1, that side is length 1. They'd be the same. This is an isosceles triangle. Okay, and this side would be actually root 2 long. And you can test that with Pythagorean Theorem, but don't worry about that. So here, anyway, I'm expecting something bigger than 45 degrees and a fair bit bigger. I think 53. That's going to be my guess. Let's see. Okay, so I'm going to type in that number, 1.6098, and then I take the inverse tangent of that, 58. I guess 53? Nah, I'm out by 5 degrees. That's actually a pretty big error. That's wrong by 10%. So, but still, see how this 45-degree triangle at least got me in the neighborhood? Because I was able to guess that way. Okay, so that's how you do those. So now let's take a look at some other examples. So if we want to solve for this angle here, now in this case, what I need to do is say, well, I wasn't told what sine, cosine, or tangent of x is equal to, but I can find that with the side lengths. All right. I first need to think about what side length is this. So you all have microphones. Shout at me. What side is this? Is it the opposite, the adjacent, or the hypotenuse?
Adjacent.
It is next to the angle, but it's not touching the right angle.
Hypotenuse.
This is hypotenuse. And one thing that I'll never forget is I saw this picture of the hippopotamus. The hippopotamus looks like this. He's a hippopotamus that lies along the hypotenuse, and he's got cute little feet. Okay, and he's got an eyeball there. And he's maybe he's sleeping, and that will make him even cuter. Okay, there. The hippopotamus lies along the hypotenuse because it's nice to lie on the riverbank. Okay, I don't know. All right, so that's the hypotenuse. What side is this? Opposite, adjacent, or hypotenuse?
Adjacent.
Absolutely. And what ratio relates hypotenuse and adjacent? Sine, cosine, or tangent? SOHCAHTOA.
Tangent.
Tangent relates opposite and adjacent. Which one relates adjacent to hypotenuse?
Cos.
Cosine, yeah. So adjacent over hypotenuse here. Cosine is adjacent over hypotenuse. So what I know from this picture is that the cosine of angle X is equal to adjacent over hypotenuse, 16 over 25. All right, now let's find out what that is. So how do I do that on my calculator, Mr. Jennings? Well, you open your calculator, you clear everything out, turn that off, okay. And then you're going to say 16 divided by 25 equals, okay, 0.64. I 0.64, that's a number, right? And that could be cosine. If you ever have a number here that's bigger than 1 or smaller than -1, that's impossible. You can't have a cosine that is bigger than that. And I'll show you why in a second. And then you go in here, trigonometry, and you say inverse cosine of that, please. That angle is 50. 50 degrees. Does it look like 50 degrees in this diagram? Did I do this right?
I mean, like, it could.
It'd be 50 degrees. Well, 45 degrees would be going up half of 90, so that would be 45 degrees. So 3, 4, 5 triangle. I think I punched something wrong with my calculator. No, I didn't. That's super strange. It shouldn't be 50 degrees. Why? Do I have some suggestions here? Who has something in the chat for me? Did I miss a step? Let's check my work, okay? I am a little bit frustrated right now. This is 4. This is 5. No, it's not. Oh no, that's fine. That's fine. Yeah, no, it's fine. Yeah, that should be good. Yeah. Okay. No, it's good. I was being fooled by a different idea. Never mind. Don't worry about what idea I was being fooled by. The idea is, don't trust the diagram because this is not drawn to scale. If we wanted to find this side, call it side A, we would say a squared plus 16 squared equals 25 squared. And we're going to find that 25 squared, well, that's equal to 625. And 16 squared is not half of that. It's much less than half of that. 16 squared is, I kind of forget, to be honest, what 16 squared is, which is sad because it's a power of 2, and I should have that memorized. Is 256, okay? So since that's 256, okay, and this is a squared plus that. So since this is less than half of that, this must be bigger than that. This in our diagram doesn't look bigger than that. So this is indeed 50 degrees, and the diagram should properly be drawn that way. So whatever we had on our calculator over here, 50.2, and we're going to round to just 1 degree. So this is 50 degrees, and that's correct. What's up, Johnny?
I'm just wondering how you got is that Pythagorean theorem you're using with like the 9 to the power of 2 or whatever? Like, yeah,
Oh, the
there.
a to the
Like,
power
how'd
of
you
2?
get to that?
Yeah, I named this a. Yeah, I named that side a, and a to the power 2 plus 16 to the power 2 should equal 25 to the power 2. I was just testing because this didn't look right to me at the time because I was being fooled by just some mental math that I did wrong. 50 degrees is a totally reasonable answer because a is less than 16. Sorry, a is going to be longer than 16. And I'm showing that here because a squared plus 16 squared will equal 25 squared. I don't know what a is, but I find it with this formula. Since this is less than half of that, then this will be bigger than 16.
Okay. Is there any way you could just show us like one more time, like how you punch it into your calculator like that?
Yeah, let's do another example here. This one. So here we have this triangle. The hypotenuse, we don't know it, but we have a side length 8 and a side length 6. And we want to know what's this angle. Okay. What side is this? Opposite, adjacent, or hypotenuse?
Opposite, adjacent, or something like that.
Yeah, which one? Can only be one of them. When we're looking from this angle, is it adjacent to the angle? Is it opposite the angle? This is the opposite. Oh, that's great. I'll be able to play with you in just a minute. Or for now, you can go play with your toys in the toy area. So this side is which side here? Oh, he had to go home. This is the adjacent side, yes. This is adjacent to the angle. So what trigonometric ratio relates opposite to adjacent?
10.
That's right. Sine relates opposite and hypotenuse. Cosine relates adjacent and hypotenuse. And tan relates opposite and adjacent. Okay, and that's your ratio, opposite over adjacent. So this is how I write it down. You're going to write down the tangent of whatever this angle is, x, is equal to 8 over 6. All right. I could, if I wanted to, reduce that. I could say tan of x is equal to 4 over 3, because that would be the same. And then what I'm going to write on my page, if I want to, is I can say x is equal to the tan inverse of 4 over 3. Okay. What I'm saying is the tangent of some angle is equal to 4 over 3. So find me the angle whose tangent is 4 over 3. That will kick out x. Let's try that on our calculator. So what you're going to do is divide, clear everything out. 4 divided by 3 equals 1 1/3. No surprise. And then you're going to take the inverse tangent of that, and that's 53 degrees. Now that makes total sense. This looks like 53 degrees because here are some bookmark angles that you're going to want to remember. 90 degrees looks like this, it's square. 45 degrees is half of that, right? Also, the line y equals x, that goes through the xy plane on a 45-degree angle. Okay, so that's 45 degrees there. This one is a bigger angle than that. It's bigger angle than 45 degrees. So the fact that x equals 53, 53.1, and we're going to round to 1 degree. Give your answers rounded to 1 degree unless you are asked for something else. 1 degree is plenty, a lot of detail. Okay, so then we got practice problems already. So that's how you do it. Do people want to see another example, or do you want to see a word problem? Or are you ready to get started on your practice? With that, I will move on myself to a Delta Math walkthrough. So thank you for showing up for your learning. And any questions, hit me up here. Hit me up in the shared doc for questions, which is anonymous, or send me an email. Ask me your questions as we go through your practice today.